In section 4.4, we are going to look at proving parts of triangles congruent to one another. We can do this by using Cpctc, which stands for corresponding parts of congruent triangles are congruent. And we can only use Cpctc as a justification after we have already proved that the triangles are congruent. Let's look at an example of using Cpctc. Number 1 says in an umbrella the stretchers are congruent and they open to angles of equal measure. Shapes are formed by the ribs. Stretchers and shaft are congruent whether the umbrella is open or closed. So we are given that SL is congruent to SR and angle 1 is congruent to angle 2. We want to prove that angle 3 is congruent to angle 4. So before we can prove that our two angles are congruent, we first have to prove that our two triangles are congruent. So just like our previous proofs, the first thing we're going to do is write down our givens. So number 1, we have SL is congruent to SR, and angle 1 is congruent to angle 2. And my reason is they are both given. Alright, our figure is already marked with the sides being congruent and our two angles being congruent. So I need to first prove that triangle CSL, so this triangle here, is congruent to triangle CSR, this triangle over here. Alright, so think about our theorems for proving triangles congruent. Remember we had SSS, side, side, side. We had side, angle, we had angle, side, angle, and we had angle, angle, side. So right now I have one pair of congruent sides and one pair of congruent angles. So I either need another side or another angle. Well, if you notice, our two triangles share that middle side, CS. So I can say CS is congruent to CS by the reflexive property of congruence. So now I have a second side, and I have the three necessary parts to prove my triangles are congruent. So third thing, triangle CSL is congruent to triangle CSR, and that's because of side, angle, side, and therefore angle 3 is congruent to angle 4. And that would be because corresponding parts of congruent triangles are congruent, which means if the triangles are congruent, then all the other sides are congruent and all the other angles are congruent. Alright, let's try another proof. So in number 2, we are given that angle W is congruent to angle X, and V is the midpoint of WX. We want to prove that angle Z is congruent to angle Y. So let's first write down our givens. So we have angle W is congruent to angle X, and V is the midpoint of WX. Alright, now I'm going to mark, almost forgot my reason. It's because they are given. And now I'm going to mark my diagram. So we have angle W is congruent to angle X, and then V is a midpoint of WX. So we have a key word here, midpoint. If you recall from chapter 1, a midpoint cuts a line segment in half, which means into two congruent parts. So that means that WV is going to be congruent to VX. So that's going to be the second thing I write down. And my reason there is definition of a midpoint. Okay, So right now I have one angle and one side. I either need another side or another angle. So thinking of our theorems, we have side, 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 angle, 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 side. Well, if you notice in our figure, we see that angle WVZ is going to be congruent to angle XVY because they are vertical angles. So I'm going to go ahead and put that in my proof. So angle WVZ is congruent to angle XVY, and that's because vertical angles are congruent. So now I have enough information to say my two triangles are congruent. So I can say triangle WVZ is congruent to triangle XVY because of angle, side, angle. And then if my two triangles are congruent, that means all their other corresponding parts are congruent. So now we can say angle Z is congruent to angle Y because of Cpctc. Corresponding parts of congruent triangles are congruent. All right, let's look at one more proof. Number 3 says, according to legend, one of Napoleon's officers used congruent triangles to estimate the width of a river. On the riverbank, the officer stood up straight and lowered the visor of his cap until the furthest thing he saw was the edge of the opposite bank. He then turned and noted the spot on his side of the river that was in line with his eye and the tip of his visor. The officer then paced off the distance to this spot and declared that distance to be the width of the river. So we are given that angle DEG and angle DEF are right angles, and that angle EDG is congruent to angle EDF. We want to prove that side EF is congruent to side EG. So let's first write down our givens in our proof. So angle DEG and angle DEF are right angles. And angle EDG is congruent to angle EDF, and that's because these two things are given. All right, now let's go ahead and mark our diagram. So angle DEG is a right angle, and so is angle DEF. So go ahead and put our right angle symbols in. And angle EDG is congruent to angle EDF. Now, we were told our two angles are right angles, but it does not say that they are congruent. So we have to put that statement in. So angle DEG okay, so now we have two congruent angles, we need a side. If you notice, our two triangles share side DE, so that means that side is congruent to itself. So we can say side DE is congruent to side DE because of the reflexive property of congruence. And now I have my three parts to say my two triangles are congruent. So triangle DEF is congruent to triangle DEG because of angle, side, angle, and therefore all of their corresponding parts are congruent. So that means side EF is congruent to side EG by Cpctc. And that concludes this lesson.